Hello everybody, welcome back to my YouTube channel. This is me, EHK, your study buddy behind the mask. Today we are going to see the most difficult question asked in my pre-boards. I don't know where they took this question from, but this is a great question as it demands logical thinking and creative approach towards solving the question. So without any delay, let's jump right in. So here's the question. A company owner employed 150 workers to finish a piece of work in certain fixed number of days. On the first day, all 150 workers worked. He dropped 4 workers on the second day, 4 more workers were dropped on the third day, and so on. In this way, work got finished in 8 more days. Find the number of days in which work was to be completed originally. As we can see in this question, there are 2 cases given. Let's see the first case. As we have read, 150 workers do a piece of work in n number of days. Now let's find the work done per person per day. This is the simple unit on which the question revolves around. To solve this equation, let x be the total work done, and let n be the total number of days taken to complete the work. Now, finding the work done by all in one day is nothing but the total work done divided by the total number of days the work had taken. So we get x by n. Now work done by one person per day, this is the unit value which we have to find. So work done by all in one day divided by the total number of people who do the work. We know that the total number of people in case 1 is nothing but 150 workers. So I'm just taking it here, x by n divided by 150, after which we get x by 150n. This is the constant value which we need to find the answer. It's going to remain constant even in our case 2. Speaking about it, let's move to that case. In case 2, we have been given that 4 workers are dropped in successive days, and it takes 8 more days to complete the same task. As it's the same task, here also the work done is x. So, the number of people who worked in first day is nothing but 150 people. The first day it was 150, and as 4 members were dropped on the second day, it drops to 146. On the third day it's 142 and goes on. This goes until the n plus 8th day, as the work is completed in 8 days more than the case 1. Now let's see the work done in the first day. As we know, the work done by one person per day as we found in case 1 is nothing but x by 150n. As I told, it's constant even in case 2. I'm using that equation here. On the second day, as 146 workers work, we are just going to take the 150 and replace it with 146. And the equation still remains constant. Now on n plus 8th day, the number of people who are working in n plus 8th day, which I am taking as a n plus 8, times of the constant value which we found. Now sum of all the work done in all these days is x. As we have discussed before, the work done is same even in case 1 as well as in case 2. And we took that variable to be x. So we can derive x is equal to work done on the first day, which is here, plus work done on the second day added to the successive things until the work done on n plus 8th day. Now we know that this constant value is there in everything. So let's take this as common out. We are getting 150 plus 146 plus added until the n plus 8. Now simplifying the equation, we get the things which are inside the bracket is nothing but the sum of an arithmetic progression. The formula is nothing but n by 2 times of 2a plus n minus 1 times of d. Here we can see that the a is 150 and the n is n plus 8, which is the number of days it took to complete the work in case 2. Now we need to simplify this equation. As such. Doing this. At the end of this, we are arriving at a quadratic equation. After simplifying that quadratic equation, we would be getting the answer. So let's try to simplify this quickly. Here we are getting 272 minus 4n and 300n is equal to 272n minus 4n square plus here 2176 minus 32. Further simplifying, we get this equation and taking this entire side to the LHS of the equal to symbol. Now this is the quadratic equation in which we arrive. Now I am taking 4 as common out to make our calculation simpler. Now, this is the equation inside the bracket. This is the simplest form of equation which I have arrived here. Now substituting the quadratic equation, we would be getting the n number of days, as n is the variable in this quadratic equation. The denominator is 2. Thus here we get and this becomes, I added 225 with it. It's actually 2176. Now adding both, we get 2401 inside the root value. Now we can simply arrive at this root because I used a shortcut method for this. To find the unit digit always remains constant. As we know, 9 square ends with unit digit 1. And the nearest square which I know is 50 square, which is 2500. As 2401 is the nearest square number along with 2500, I am taking it as 49, which is the predecessing number of 50. Now we are arriving at two answers here, which are n is equal to 17 and n is equal to minus 32, where this negative integer is neglected as days cannot be negative. Therefore, the number of days is 17. The value of n is 17. And this is the initial number of days. That is the number of days the work was to be completed initially in case 1. So number of days in case 2. As we know, it's 8 more days. So 17 plus 8, we are arriving at the answer 25. But they have asked only for the initial number of working days as asked for the original value. So it's nothing but 17, which is the initial value which we got. So the answer is 17 days. Hence proved. With this is me, AHK, signing off. Thank you. Have a nice day.